It might be a little scary, but not. So, like I said, there's this thing called the law of sines. Law of sines is for when right triangles we don't have a right triangle. And you're going to use law of sines. We use when we know an angle and its side opposite. So basically what's going to happen is when you have a triangle, we'll have 3 sides and 3 angles. Pretty easy. Okay? When we use this thing called law of sines, we're basically going to be using a scenario like this. Well, we will circle an angle and circle the side opposite it in order to set something up. Okay? Can you spin your desk, please? I asked you guys to keep the chairs the way they were. Thank you. So what happens is, this thing called law of sines, you get one giant ratio. Remember, ratios are just a whole bunch of fractions that are set equal to each other. And it's going to look like this. And it is a very simple scenario. The sine of an angle is to its side opposite, as the sine of another angle is to its side opposite, as the sine of another is to its side. Obviously, there are 3 fractions here. You're going to use any 2 of the 3 to set up the solve. It'll take a second or 2 here to write this out. And once we get an example going, you'll see, oh yeah, that makes total sense. It's pretty quick. Okay? It's pretty quick and painless. What's that? Oh, sure.
What is that?
What?
Science.
Okay.
Yeah, I'll get there. That's it. Quick examples.
Exactly. All right. So what will happen, like I said, is we're going to use this thing called law of sines to solve triangles that aren't right triangles. It's for when we have a side and an angle opposite it. As we go through these things, it's just a matter of drawing pictures, and you'll notice that we're going to wind up doing a bunch of cross multiplying. Okay. Sometimes you can solve for an angle, sometimes you can solve for a side, and then it's just a matter of piecing it all together. Okay. For example, let's just do a really, really easy one. Oops. So let's start with this. We have triangle ABC. We have 2 angles and 1 side given to us. Okay. 35 is at angle A, 48 is at angle B. A lot of times with these things, guys, I might just list the angles and list the side for you. You just have to draw the picture, which you guys all know how to do. That's not a big deal. Okay. There's nothing, we're not trying to make them super fancy. We're just making real generic pictures of a triangle. And, what's that? I'm well, sir, I'm well. So, when you look at this picture, do you see how you have an angle and a side opposite? What angle do you know in the side opposite? At B, correct. You've got big B, this is little b. There's angle C, this would be little c, and angle A, this would be little a. So remember, sides and angles are opposite one another. Okay? Not too crazy. So what I do is this. I always circle the angle and the side that I have opposite, because I'm going to use that to solve for everything else. Okay? So here's what happens. We know angle B, side B. We know angle A. We need to find side A. You okay with that? So basically what I'm doing is I'm going to use this setup. The sine of angle B, I'm going to write it out long form first, is to little b, as the sine of angle A is to little a. And then I'm going to fill in the blanks. Okay? I fill in the blanks. So, in this case here, what's angle B? What's little b? 28. So I'm just writing that in. Sine 48 is to 28 is to sine 35 is to little a. Everybody with me so far? So in this case, notice you've got 3 parts of the 4 fractions. You have 2 numerators, you have 1 denominator, you got to solve for the other one. And what happens here a lot of times, guys, it's just a whole bunch of cross multiplying. Okay? Remember, the sine of 48 is just some crummy decimal. The sine of 35 is just some crummy decimal. So we're going to move some stuff around just like we have in the past. We're going to rewrite it before we press any buttons, which I know you guys all can do. Okay? So, in this case here, I need to move this 28 up there just by multiplying. We all know that, right? And then, since my denominator is the unknown, I do an exchange-o, change-o there. Okay? So I am. I'm going to multiply by 28, so I get 28 sine 35 over A is sine 48. Okay? So now, what I need to do is I have to multiply by the denominator over. Again, I'm just doing this long form. I probably have to hopefully only do that once. Multiply both sides by A. So you have A times the sine. And remember, how do you undo multiply by a crummy decimal? You divide by the crummy decimal. What's that? Right, what? I'm getting there. I'm just doing the long form first, okay? I can't hear you.
I don't know how you work it
What do you mean?
out. I don't know how you got from the fraction.
I multiplied by 28. How do you undo divide by 28? Multiply by 28. That's what I did. That's what I got to here. Yeah, you're just undoing it. Okay. So I multiplied by 28 here and here. Guys, this is just a two-step algebra problem. You guys all know how to do that. Okay, I hope. It just looks different because there's letters with numbers. Okay? That's all this is. What do you mean?
Proportion.
Proportion. Remember when we did this a long, long time ago? When we had 1/2 was the same thing as 3/6. I can exchange-o, change-o on the diagonal. 6 over 2 is the same thing as 3 over 1. It's still true. That's what exchange-o, change-o is. You can, whenever you have fraction equal fraction, you can exchange them along diagonals, and it's still true. That's where that comes from. Right? Because I'm doing it long form here. And then you wind up with A is okay, this is what we wind up with to get your side A. Now, if you look at where we started excuse me, at the sine of 48 was 228, and that equaled the sine of 35 is to little a. Okay? If you look at where we started to where we ended up, notice all I did, I multiplied up by the 28, and I switched the 2 on the diagonal. No problem. Is that where you're getting at too? That's all you're getting at too. Did you get it though? What'd you have? Got it. All right. And again, as we go through these things, obviously it's the first time you've seen this quick algebra setup, but it falls into place because it's the same scenario over and over and over again. Okay. Now you guys all have calculators. You guys all have fraction bars. We type this in to get our side in. Helps if I have, probably use mine. Guess I need to start up the other one. Give me 1 second here. Oh, you don't have to apologize. No big deal. So let's see, we would do a fraction bar. 1 second here, I have it here. So 28 sine 35, and then over sine 48. And I press enter. What's that? It's okay. And I get 2161 for a little less. You okay with that? All right. Notice, use fraction bars and that thing works out real nice. Okay. So you wind up with little a being 21.61. Always go to decimals. Okay. Now we still have to find angle C and then the little side of C. Well, in this case, you have 2 out of the 3 angles in the triangle. What do all 3 of them have to have equal? 180. So that's the easy thing to find, isn't it? Okay. Same idea. So if I take 180 and I back out 35 and I back out 48, what are we left with? What was it? 97? Okay. So I know that angle C has to be 97. So what we wind up doing then is we do the exact same thing to find the side C.
Is it not a A or B?
What do you mean?
Like when you set the equation and you're doing a constant multiplication, does it matter whether you're using the sine of A over B equals sine of C over C, or do you use A?
You can use the A, but the only thing that I would suggest, you found that.
Yeah.
What if you press the wrong button?
Okay.
So I would always go back. That's why whenever I have something given to me like this, I always circle it because I'm going to use it. There will be a time that you're going to have to take a leap of faith that you have correctly and have to redo some stuff that you found. And this is the case that this happens. By now, most of the stuff, there's less buttons to have to worry about. It's usually just, you're always just hitting sign with these things. You don't have to worry so much. So we would do the exact same scenario. Let me move this over just a little bit. I would have the sine of our 48 is to 28, as the sine of 97 is to little c. And notice how the movement of the values are the same because I'm still trying to find a side length. I change-o the diagonal of c, and I multiply by the 28 to the sine of 97. We just move things around. Okay? So you get c will equal 28 sine of 97 over sine of 48. Change-o, multiply by the denominator. The same exact scenario from what you just saw. And that's the other thing that'll happen a lot of times. You're either going to be solving for an angle or a side. If you're solving for the side, the mapping of it, the setups, are always the same. Moving this stuff around. If you're solving for an angle, which we will eventually, you just have to do an inverse button. We'll get to it. All right. Again, I would go to my calculator and I start pressing some buttons here for this. We would have 28, let's move this over. 28 sine 97 over sine 48. I got little c, and when I round that to two decimal places, what would you do? 0.4, very good. 37.4. Now here's the thing that kind of sucks with this, to be honest with you. Oops, wrong button. What did we say it was? I forgot. 37.4. Now, if we were working with right triangles and you had side lengths, how could you always double check? Remember how you can always check that in theorem to see the sides are right? In this case, you really can't because they're not right triangles. So the only thing you can really do to see if you're kind of on the right path here is, does the largest angle have the biggest side length across from it? Remember our little trick of just using your hands to open them up? If you go back and look at that, if you've got the biggest angle has the longest side length, the smallest angle has the smallest side length, you're probably on the right path. Okay? It's one of those little weird ones that we do. As you can see, the math setup of this isn't tough. It's just a lot. This is a lot of buttons. Okay? More so than I think of the tricks, the right triangle stuff. Right? That wasn't terrible, was it? All right, let's try another one. Let's try another one. What's that, buddy? I think that's what we got. Yeah. Yes. 37.4. Correct. And I just filled it in. A lot of times with these things, what you know how we did with the right triangles? I always put side lengths and stuff you're looking for. I'll do the same thing for you guys and write them out so you know which ones you're finding. That way you have a place to put them. But you have to remember to read them correctly. All right. Let's see here. All right. Let's set it up once without a picture and see what we have to do. So what should you do first? Draw a triangle. Right? First thing we'd always do is just draw a triangle. Does it have to be accurate? It just needs to have what? 3 sides because it's a triangle, okay? Label it A, B, and C. It gave you angle B, so where do you put angle B? Get angle B. That's not rocket science. C is at 46, and we know little c is 18. Okay. In this case here, I just wrote down, just for argument's sake, not to get too far into it, if I just wanted to find side B, do I have an angle and a side opposite? Yep. Correct. Very good. So what I always like to do, bless you, I always like to circle, bless you, I always circle my angle and my side opposite. So that way I know to use that one, like you just said, David, as the sign of the angle over the side opposite. I use that as its pivot, if you will, that you're going to reuse multiple times later on, because it's given to you. Remember I always say reuse your givens? This is another scenario where we reuse givens. Okay? So we write it out. The sine of 46 is to 18. Very good. Little b, yeah. Yep. It's the sine of 17 over little b. Boy, does that look exactly the same as we were just doing a minute ago, wasn't it? See what I'm saying? That a lot of this is repetitive. Okay. Change-o, multiply by a denominator. So I change-o these two. So b will equal sine of 17 over sine of 46. And then I have to move the 18 up here. And now I can type it in exactly the way that it's written. That's why we always write out what we're going to put in the calculator before we do it. So you can see what you have to type in. Okay? It's a nice little trick that I try to make sure I show you guys. Let me check it here real quick. Let's say you're wrong. So 18 sine 17. And then sine 46. 7.32, very good. So I got little b at 7.32, or David got it, I just agreed with him. Alright. Not bad, is it? Yes, ma'am. For log signs, yes. If you know an angle and the side opposite, you will use what's called log signs. If we don't, we'll use what's called log cosines. Log cosines is something different we'll do tomorrow. It's another algebra equation. Oh, don't have to memorize these things. I'm going to give you these equations anytime we have a task or quiz on this stuff. So this stuff on Friday, I'll give you the equations. You'll have it in front of you. But then you just have to know how to use it. Same thing with the final. So log cosines, we'll do that tomorrow. Again, it's just a straight two-step equation. And then once you get log cosines, then you'll have an angle and side opposite, and you just use log signs. It's a sad one, isn't it? Okay. All right, let's try one with an angle. All right, let's try this one. So we have A, B, and C. We'll try it. The other way that this can happen is we have to find an angle. This is the weird case that'll happen when you guys get to algebra 2. The side-side angle, if you will, that we told you never existed. So there's a weird case that something does exist with that. Don't worry about it. When you get to algebra 2, when you use law of signs, there is a possibility you can have what's called the ambiguous case, which means you can have more than one triangle. So don't worry about it. Just not smart, not even politely. All right, what is this one forcing us to find first? It's forcing us to find angle B. Everybody see that? Because what angle do we have and what side do we have? A. So we're given side A and angle A. So again, I always circle what I'm given. I'm given that. And notice we have side B, which means it's forcing us to figure out angle B. So we write it out like we would normally. The sine of 33 is to 27 as the sine of B is to 40. Right? Now, we all know when you have to find an angle, what buttons did you have to press on the calculator yesterday? Yeah, the inverse stuff. Okay, we get the sine -1. We use those buttons. But in order to do that, to get this to be able to do that, I have to move the divide by 40. So how do you move the divide by 40? Multiply it. Then you would wind up with just 40 sine of 33 over 27 is sine of b. Okay. Now remember, this represents some crummy decimal. Okay. We need to find that crummy decimal. So we type it in. Move over here. So fraction bar, 40 sine 33 over 27 and hit enter. There's my crummy decimal. This crummy decimal equals the sine of an angle. Remember when we did that before, we were just inversing. So now what we have to do is hit second sine of your angle, of your answer. Just like you did yesterday with the right triangle trig stuff. The only difference is the first part you're typing in is just a little bit longer. Other than that, the process by which you find the angle is exactly the same as what you guys did yesterday. And what we've been doing for the past month and a half. Yes, sir. Yeah, but don't type it all in like that right off the bat. Get the decimal value first, hit enter, then do your inverse off of that. That way, too many times people, and I'm speaking from experience, I've seen too many times when people try to type all that in at once, something's going to screw up. So, and then just hit enter. There's my angle, 53.79. For B, yes. So what I say was 53. Now, now is where I have to take what we found to use. How many degrees are in a triangle? 180. If I now have two angles, I have to subtract out then to figure out what's left over for angle C. Okay. This is where, once you start going with law of sine stuff, when you have to find an angle first, you're going to have to cross your fingers that you press the right buttons because there's really no way of double checking yourself. Do not write on my desks. Get your hands to yourself. You're not a 7-year-old. If you need paper, extra paper to write on, by all means, have some. Do not write on my desks. Yes, Andy? We typed in this, got the desk. Didn't I say? Did I write? I said 79. I said 97, but I meant 79, didn't I? Sorry. I'm getting there. Yep, so now you've got your two angles, so you back those two out, what you get left over. When you subtract out, what you get? 93.21, everybody else agree?
Yeah. So
down here we're at 93.21. So now I reuse it one more time to find the sine. How many degrees are I finding? And you're back to solving for a side, which we did second note. You'll have to do an change of, and then a multiply over. Okay. There's a lot of crummy decimals with this stuff, guys. That's the only downfall with these things. It does not give you very clean numbers out more often than not. Okay. So once again, moving our stuff around, we would wind up with little c would be 27 sine of 93.21 over the sine of 33. So 27 sine 93.1 over sine 33. 49.5, yeah. I go 49.5 on that. Okay. Might round that out to 2 decimals. And that's the other thing, you want to try and don't, oh, never mind. Sorry, I was thinking something else. So 2 decimals give me 49.5. Okay. Hopefully it isn't. Oops. So, like I said earlier, if you look back at our angles and our sides, 93.21 is the biggest angle, isn't it? Is 49.5 the biggest side?
Yeah.
Okay. 33 is our smallest. Is 27 the smallest? That's really the best that you can do with some of these things, is to kind of take it with a little grain of salt that you set it up correctly. Okay. As we go through. All right. Let's try another one. That's a B up there, I guess. It clipped it a little bit. So we have little a, little c, little b. Take a minute and solve the triangle. When I say solve the triangle, that means how many parts you need to find things. 3 of them. You're always given 3 to start with, just like we did before. But now you just don't have the right triangles. Right? So, and before anybody asks, there is no such thing as log tangents. There's log. What's that? There's log cosines. Like I said, we'll talk about that once in a while. Again, it's really fast. Log cosines is really fast.
So why is it?
It has to deal with the domain of tangent. It is not continuous.
Okay.
Let's see. Movements are good. So, sine of 16 is to 11, as sine of b is to 12. You can't, because you don't have any sine a. You can't do that. You have to go with what you're given. You're trying to find this one first because you have that. Okay? So you have 12 sine 16 over 11. Yeah, I had that one right. 17.5. Okay. So my 17.5 is for angle B. Okay.
Yeah.
Oh, I didn't divide it by. Write it out. Okay. Oh, I bet you, did you just do silent, did you do over 1 by mistake? Did you get those two ones? You did, didn't you? What you did? Did you? There you go. Now here's the thing. Did you write that down though?
Yeah, right.
So here's what sucks about law signs. It's not that the math part is tough. You guys can agree that the mathing of it is pretty simple. What sucks is you write down the wrong thing. Okay? So what David did, he wrote down over 12 by mistake. And then you had to use that again and use it again. But here's the thing. And you did that wrong by writing the wrong number down, but you did it all correctly. Are you really wrong? And that's what sucks about these things. It's tough to go back and do it. So please, I'm glad you wrote it down so you can see it. So every one of your other numbers is going to be off by a little bit, but if you set it up the right way, you're fine. And I'm okay with that. I can't fault you for not knowing what an 11 to 12 is. I wasn't there at that grade level.
So what I did was I wrote 16 and sine 16 over 11 equals sine 12 over 11.
Oh, yeah, careful. Yep. Yes, that's totally right. Remember, the big E is the angle, little b is the sine. Okay. So then we get through that one, and then then we would use subtract from 180, and that's where I got the 146.5. I'm sure, is that right? Does everybody double check me on that one? Thank you. And then I reused that one again. I did the sine of 16. One more time is to 11. As the sine of 146.5 is to little a. So this would have been 11 sine of 146.5. Let's see, 11, to make sure I did that right. Oops. 11 sine 146.5 entered over sine 16 entered 2203.
No.
But you started wrong, so it doesn't count. All right, and that's what we're looking at. 2203. Okay. I'm not trying to make this stuff super crazy with this stuff here, guys. It is quite literally not straightforward for setting up and solving. We don't want to make this. There are so many other weirdness things that can happen, but for right now, so we'll look at it. What'd you say? Put the other on? Yeah. Okay. So, what I want you guys to try out tonight is I got 4 of these. Okay. It's not 4. Just 4. Okay. There's nothing too crazy with this because what we wind up doing is tomorrow we start with what's called law of cosines. Law of cosines is for when you don't have a side and an angle opposite. So with law of cosines, it'll allow you to get that side opposite, and then you can therefore use law of sines. It's nothing more than formula work. It's just how we set it up. No problem. And what I did here on this sheet, guys, I labeled them with just the 2-letter side stuff. But if you wanted to go back and change them, if you wanted to look at it, excuse me, you start thinking about what this should look like. If I'm looking at number 1, no. What is that forcing you to find first? Angle B, okay. I wrote down there, and I probably should have switched it. I said find segment BC, but we're going to call that little a. So make sure you write that in, that's your little a. All right. Number 2, your little a is the BC part, your little b is the AC part. 26. I get my numbers mixed up today. Okay.
That's not good.
And then on number 3, no, there isn't. On number 3, little c is off to the for AB, and little a is up there because this is little b. Yes, going back, I probably should have wrote those in beforehand, but oh well, not a big deal. Just so you guys know where all the little parts go. All right, give those a shot. I probably could have put these on front and back, but write out what you're doing before you do it. Circle the given values, okay? Circle the given values. So on number 1, you're going to use angle C and little c across from it to solve it. On number 2, you have to find angle C first to do it. Okay? Same thing with 3, you got to find angle B first. And then lastly, on number 4, you'll use B and side B to solve the other parts. Okay? Also, might not be a bad idea to write down the law signs on the sheet. Remember?
The law of sine.
Sine of A is the little a. Sine of B is the little b. Sine of C is the little c. Okay. I have that on there as well. Again, it's nothing too crazy as you go through. You guys should do well with this. All right.
Thank you.
No problem. Like I said, it wasn't so bad, was it? No. It's a lot of fun this year, guys. It's about time. It used to be the hardest. You can't even get your head out of your